Hello everyone, this is Rudra Jaggi and I'm going to be explaining the Sutherland-Hodgman polygon clipping algorithm and how it works using demonstrative examples as well. So what's the use of this? It is used to clip a polygon by processing it against the window of the clipping window. Now our clipping window typically would have four boundaries, which is the left boundary, the right boundary, the top boundary and the bottom boundary. What this algorithm does is processes all the vertices against each clip of the clipping window, which starts with left, moving on to the right, then to the bottom and to the top. Now let's take up an example over here. Here we have this star pattern and this dotted rectangle is our clipping window. So first of all, the polygon, which is the star, will be sent to the left clipper. Now what happens is this part here, which I have highlighted, is out of the bound, so it gets clipped by the left clipper, and then again it is sent to the right clipper because LRBT, that's the order right here. Now this part on the right, it is outside the window, and as you can see, it gets clipped here. Now they will move it and send it further to the bottom clipper. Now we have two parts here in the bottom which are not in the clip, and they get clipped right here as well. Now finally the algorithm will send it to the top clipper, and in the top we have this shaded portion over here, and that also gets clipped, and thus we can obtain this polygon clipped figure onto our window. Now how the algorithm achieves this? It uses four case scenarios in which the pair of the vertices of a line, like here we have 1, 2, 3 vertices. So these vertices are used, and only the vertices which are into the clipping window are given into the processing output list. In this example right here, if the first index is outside the window and the second index is inside, so first index is outside, second is inside, then both intersection point of the polygon with edge of the window, which is right here V dash, and the second vertex, which is inside, they both are added to the output list, and this one is removed, thereby this whole portion is removed. In the second case scenario, both the input vertices are inside. Here we have V1, V2, both are inside. Then only second will be added because they both are inside anyways, and this part, these vertices are ignored and thus they are removed. In the third case scenarios, the first index is inside the window and second is outside. Here this one is inside and this one is outside. Then what happens is that only the intersection point is added. Here this intersection point, this will be added into the output list, and everything onto the right of it will automatically come, and this portion will be omitted. In the fourth case scenario, in the final case scenario, what happens is both input vertices are outside, then obviously nothing will be added because we don't need that part. So this whole portion is ignored, and finally we get our clipped polygon, just like into our star pattern. The same thing happened. This vertices was outside, this whole pattern was ignored. Here these vertices are on the point, so this pattern was involved, but everything else was removed similarly. And now let's take up an illustrative example right here as well. Suppose this part is my clipping window. I'll assign a different material to it so that it can be easily identified. Okay, so that part is our clipping window and this is our polygon. Now left portion first. There is nothing on the left that is outside the bound, it doesn't need to be removed. Now LRBT, coming to the right portion, nothing is outside here as well, so we don't need to remove it either. Now on the bottom I do see some things going outside of the clipping window, so I'll go here and select my extra vertices, and I'm gonna just remove them. Now you can see it is perfectly aligning into the bottom. Just see the shaded area. Now coming to the final step, which is the top, LRBT, left, right, top and bottom, bottom and top. So over here this extra part is outside the clipping window, so I'll just tab in and remove it as well. these are the extra vertices, so I'll remove it. And coming here, you can see this is the part, this is the polygon, the yellow highlighted region, and it is inside the clipping window successfully. So that's just how this algorithm works. Now, one exception that we do have in our algorithm is it works correctly with the convex polygon, but in case of convex polygon, some extraneous line may appear. Like right here, this part right here can appear into our final output in case of concave polygon, because it joined these the algorithm will join these vertices which are not actually joined into the figure. So this is it. Thank you so much for watching the video.